All right, lesson 9A, exponential function. Last time, very last time, like last year actually, we learned about parabola, right? What does it look like? Umbrella? A U, right? It's like a parabola. The name is parabola like this. So that's what we learned. And then last unit, we learned about square root radical function. What does it look like? Huh? That's a straight line, not two, not. You remember last unit? We just did the test. What does it look like? Oh, that's crazy. What a saw is like, you like dancing around. Okay, yes. Yep, okay, 1 point for Jose. It's like this. Yeah, right? So today is exponential function. Okay, it's gonna be look like, who remember the question number 20 on the aspect. Y equal to 2 to the x. Very good. 1 point per synonym. This is something we're gonna talk about, but we have the general. It can be number 2, number 3, number 4, something else. But that's what we're gonna learn. Okay. Let's say I want to graph this. What is the method that I need to do in order to graph? In order to sketch a graph, what do we need? Always 1 point. Huh? T-table. 1 point for Elizabeth. T-table. Remember that always, if you want to graph something, you need to have a T-table. Okay. Here, this specifically function, if you want to graph it, I think this is the easiest type of problem you want to graph this, because you don't need to figure out what number is here. It's always fixed. 3 number. Let's make it fun. Who can guess? It's just random, like you play in lotto. Huh? 3 number, okay? It's fixed. Every time you want to graph something like this, only 3 number. Zero. Okay, have you 1, 0? 1. Huh? 1. Okay, you have 1. Who said -1? Yeah, okay. -1. So I have Rola Montano, Orlando, and Andrea. Oh, yeah, that's me. Only, okay, Mark. Only the 3 point. You're gonna fix this 3 point. Those are the point that you always choose this. You don't need to worry about any other number. Just this 3 point. Easy, right? So tell me, when you plug in -1, what do you have? So 2 to the -1. What is 2 to the -1? -2. 2 to the -1 is -2? 1/2. 1 point Elizabeth. Do you remember the negative on the power? How can we take care of the negative on the power? You flip it, right? So 1/2. Remember this. Not -2. Okay, not -2. All right, next one. 0. 2 to the power 0 is 0. 1. Not 0. Everything to the power 0 is 1. Okay. And then last one, 2 to the power 1 is 1? 2 to the power 1 is 2. Okay, now you have 3 points. Okay, plug it in. -1, 1/2. Okay, so -1, maybe 1/2 I put over here. So this point. 0, 1, 0, 1 right here. 1, 2, so 1, 2 right here. Okay, so this is how the graph look like. Let me see. Okay, let's say this is 2, 2, 1. 1, 2.
Wait, why does it start off like a straight line and watch it go into like?
Good question. So they give Mark 1 point. Good questions. So this left side, they will keep going to, what does it mean? Keep going to where? Infinity, right? The thing is, do you think this line gonna go lower than the x-axis? Why? Why do you think this never go lower than 0? Who I can answer this, I can give 3 points because it's a good question. Good answer if you can see this. Good. Actually, you've Anthony 3 point. It can never be negative. Is there any x when you put it in here? You can get negative number? No, right? That's the reason. That's the reason. Very good. So yeah, so this is the sample of what the function, exponential function, gonna be look like. So in general, it's gonna be like this: y equal to ab to the x. Okay, this is the general of exponential function, where d is the row factor. This is the row factor. What is the condition for a? What number a cannot be? No. Zero. Good. 1 point %. A can never be zero. Why? Because if a equal to zero, what happened? Everything is zero, right? Y equal to zero. There's nothing you can do. Okay, so a need to be non-zero, not zero. And we're gonna learn a new vocabulary today. It's called asymptote. Okay. Who know what is asymptote mean? Who know what is asymptote mean? Okay, never mind. It takes time. So asymptote is the line. The line that the graph approaches more and more closely. So in this assembly, which line you think is the asymptote? Like the graph approaches more and more closely. It keep going close to that. What do you mean? Which one? Huh? What line? What line? I think you got the idea, but just tell me specific what line. This one? This one? This one? This one? What line? What line? The graph keep going. What does it mean? What does it mean? Huh?
The definition.
Oh, okay.
The one on the bottom.
That is the line?
Yeah.
What is it like? What is the name?
X.
The x-axis, right? Okay, so one more, Yasmin and Serene and Adrian. It's the x-axis. In this assembly, is it the x-axis? So this, and because it's horizontal, so actually we call them horizontal. Horizontal, I cannot spell. Horizontal asymptote. Okay. So this line is very important because it's going to show you where the graph cannot be crossed. So the graph can never go low on this horizontal asymptote. Okay.
There could also be a vertical one.
No, in this function we only have horizontal asymptote. Very good question though. All right, let's start drafting an assemble. Can I erase this? You got this? Yeah? All right. We're gonna finish very early. All right, so assemble 2, let's say this is assemble 1. The one we just did is assemble 1. Oh, no. Not continue. I want to introduce, there are 4 types. So there are 4 types. So when you wrap this exponential function, they will fall into these 4 types. Only these 4 types. So first one is, I'm gonna leave it blank. You're gonna guess. Okay, and the second type is exponential. You're gonna guess. Can I erase this one too? Yeah. Okay. And then D. I have less and less space to draw. Right. Now we have so many pictures here. All right. The first one will look like this. Huh? This one? Exponential. But there's a blank because of you don't figure out. What do you think? What do you think the last one look like?
This one.
Good. 1 point for Yasmin. Good like this. Right? Only 4 types. If you graph this, they must be fall into this 4 type. If you get something crazy, not like this, that means wrong. Okay. All right. What do you think? Is it exponential growth and exponential decay? So there's 2 things. What do you think? Which one is growth? Which one decay? Is it what is A? Growth, right? Obviously, this is growing. So this is exponential growth. And this is exponential decay. Right?
Going down.
Going down because it's going down. You can see it's going down, right? And C and D is C and D is we flip this thing. Do you see that if I flip this one over the x-axis, I got this one? Yeah. So this is also decay, but we don't really need the name for this because they just flip over this one. And this one is also growth, but this one is flip of what? Flip of this one. So when you flip, if you remember the rough transformation, when we have a negative, you're gonna flip this. Yeah. So this one flip is become the C, and D when you flip it, you become the D. So actually we don't need the name, but actually exponential decay and growth as well. But this thing is just flip over axis. Because no one gonna ask you, oh, is it exponential growth or is it exponential decay? But you need to know the road gonna look like this, decay gonna look like that. Okay, only 4 types. Now we can start the example. We only have 6 examples, so it's very fast. And I don't think we need the step by step for this one because basically only 2 steps. You draw the horizontal asymptote, you make the t-table, that's it. So I don't think we need the step by step. Very easy. All right, example 2. The first one we already did. Oh, actually, let's start from 1. Let's start from 1. So the other one is like introductions. Y equal to 4x. All right. The very first thing I want you to do is find the horizontal asymptote first. What is the horizontal asymptote?
The line that the graph approaches.
Yeah, I know. Yeah, good. That definition. So what is the horizontal asymptote for this one? Just it. Yeah, the x-axis. Right. So this one. So this is the horizontal road HA. What is the second step? T-table. What are 3 numbers we always use? I will explain to you why we use those 3 numbers. Negative 1, 0, 1. Good. Okay, I think if 1 point Selene and Orlando. All right. So when I put 4 to the negative 1, what is 4 to the negative 1? Negative 4? 1 over 4. Very good. What is 4 to the power 0? 1. What is 4 to the power 1? Huh? 4, right? So negative 1 and 1 over 4. Negative 1, 1 over 4 maybe here. And then 0 and 1, 0 and 1. So this 1. And then 1, 4, 1 here, 1, 2, 3. Let me longer a little bit. 4 right here. So right here. All right, I have a question for you. You're like, no, I'm fine, Mr. You don't need to ask me. Just do what you want. Okay, why I only choose negative 1, 0, and 1? Think about this. If you go answer it right, I'm gonna give you 3 points. No. Why I only pick this 3 point? Think about what if it's not those 3 points. What if it's another point? Well, we don't really, yeah, it's the simplest one, but it's not really the right answer though.
The other one would be two squared out.
Good. So combine those two. So maybe two for Anthony and two for Mark. Let's say if I choose the number 2 and 3 or 5, it's gonna be ending somewhere around here, right? We cannot tell anything. I mean, those information is not really important because we're gonna take this portion. Or if the number is too small, like right here, you're gonna take this portion right here. But the more important part is right here, the curve, right? And the curve always happen at -1, 0, and 1. Why? Why the curve always happen at -1, 0, and 1? Only this portion every time. No matter what number it is, no matter what number it is, they always happen at -1, 0, and 1. They never happen over here or never happen over there. Why the curve always happen over here? Why?
Because of the, how would it be as the,
What do you think? Why? Huh? Oh, my question, why the curve? See the curve right here? The curve? Why the curve always happen at -1 to 1? Why only this portion? Why it's not going to be happen over here? Why it's not happen over there?
Those are the numbers always given.
Say again?
The numbers that are always given and then
Yeah. But we purposely chose this, right? But why? Why the curve always happen this? Because they always happen over here. That's why we chose this 3 point. But why? What do you think? Think about this. What do you think? No matter what this number is, the curve always happen over here. Why? Think about what happened when you plug in those numbers. What number you always get? What number you always get? Which one? Why?
zero?
Yeah, right? Is that true that when you plug in 0, no matter what number it is, to the power 0, they always 1, right? So that is the reason. That is the reason. That's why the curve always happen over here. Because no matter what number is, you go get to the power 0, you always get 1. So because I give you the hint, so I give you 1 point. Who said that? I forgot. So Mark, right? And we got a bit with okay, 1 point for
Wait,
Mark.
sorry, how do you determine if it's exponential growth or decay?
Hmm?
How do you determine if it's
Yeah.
really
How?
exponential growth or
Do
decay?
you remember the aspect review? We did this. No, the star, right? The stars test. There are questions about what is the exponential growth, what is exponential decay, and what did I tell you? How do we know when it's a growth? How do we know it's a decay? Who remember that?
When it's like 4/3, that's growth, and then I think 1/4 is the.
Yeah, you're right. You're good example. But so what is the meaning? When? In general, when? No, it's a fraction. 4/3 fraction. When is growth? That's a good example. You can use that example. So yes, so 1 point for Lando, 1 point for Jose. When is it larger than 1? It is growth. It's less than 1 is decay. So like 1/3, right? 1/3 is decay, 4/3 is growth. Yeah. Yeah, you can write down too. Remember the formula right here, you can add on right here. You can add on right here. The row factor, right? On your note, look at your note. We did write this. Row factor, so you can write like this. Okay, B less than 1 is decay. Less than 1 and larger than 0. If B larger than 1 is growth. Okay. That's a good one. That's a good questions. 1 point for Mark though. So it's a good question. Do we get this? Can I erase this though? Yeah. Yes?
Yes.
Okay. You see that you roughing this is very easy, very fast. Only 2 steps. It doesn't take any space. All right, we're gonna have 6 examples. So all right, that thing about this first. All right, that would be all we have. Who can tell me where is the horizontal asymptote? 2 points. When you see my ball like this, that means something tricky. Huh? X what? That's not easy. That easy. It's not easy, I don't give you 2 points. Where is the horizontal asymptote? Don't look at me, look at this. What is the difference between this assemble and the previous assemble? So, what do you think? Exactly. 1 point was in there. Oh, that's 2 points, right? 2 points in there, yeah. Because this you, what is it move? What move is this? Left, right, up, down. What move is this? Up, right? So this one up by 1. Up 1. So the horizontal asymptote, they're gonna move up by 1. So they're gonna be y equal to 1 right here. So this is horizontal asymptote. Okay. Yeah, does it make sense? So based on a number as well, based on the number that you can, you decide the horizontal asymptote. They're not always on the x. Remember that. Now the easy part, plug in the number. So 2 to the power -1 plus 1. What is this? I take it back. I don't think. If you make a mistake on doing this, I think it's mainly come from the calculation. So make sure you calculate it right. Okay. What is 2 to the -1? 1/2. Okay. So 1/2 plus 1. What is 1/2 plus 1? 3/2. Yeah, very good. 3/2. So this is 1.5, you will. Okay. 0. Plug in 0. 2 to the power 0 plus 1. What is this? 2 to the power 0 is 1. 1 plus 1 is 2. Yeah. 2 to the power 1 plus 1. 2 to the power 1 is 2 plus 1 is 3. Okay, so you have 3 points. -1, 1.5. -1, 1.5 around here. So this is 1.5, like 3 half. Okay. 0, 2, 0, 2 right here. 1 and 3, 1, 1, 2, 3. This is 3 right here. Did you see that they never go below the horizontal asymptote? And also, if you draw it, I want you to draw above it. If you draw it like this, it's not correct. I'm gonna take point off. So be careful. Don't be like careless and just yeah. And then it's gonna if it pass the line, I'm gonna cross take point off. Because it can never pass the line. It can never pass the horizontal asymptote.
It will
Okay.
always be above the asymptote.
Huh?
It will always be above the asymptote.
They always no. Depend. If this negative is going to be here, if you say like this, they never crosses. That's make more sense. That's make more correct. So if the graph over here, they can never go above this. If it's on the top, they can never go below. So they can never cross this. Yeah, they can never cross it. All right, are we good? Number 2. Yeah? Can I erase it? All right, number 3. All right, can you tell me where is the horizontal asymptote?
1 down.
1 down, very good. 1 point for Orlando and 1 point for Timara. I think she got that too. So this is the horizontal asymptote. Right? What point we gonna choose? Always. Awesome. All right, plug it in. -2. Be careful. Okay. How many negative are there? 2.
3.
Right. 3. Where did you get 3? I mean here. I mean on the power. On the power. On the power. You have the negative on the function already, and then you plug in the -1. So you have 2 negative. Negative and negative is positive. So be careful. Okay. You have negative here already, and now plug in -1. I'm gonna choose a different color so you know. And -1. All right, because negative and negative one positive, so I have -2 to the power 1. You don't really need to write it, but okay. What is -2 minus 1? -2 minus 1.
-3.
Huh?
-3.
-3. Okay, 1.47. That's so easy. But no one say it. All right. What is this equal to?
-2.
Very good, -2. So negative and 2 to the power 0 is 1. But you still have a negative outside, so this is -1. I have a question for you too. What is this equal to? Are they different or are they the same? They are different. Okay. What is the answer for the first one? 1, because they have a parenthesis. This one doesn't have parenthesis, so you still have a negative outside. And this is 1. So they are different. Be careful. Okay. So what is -1 minus 1? -2 or 1.47. And 2, -2 to the power 1, but I have the negative there already. So I have 2 to the -1. What is -2 to the -1? -2 to the -1. What is this? Huh? What? Tell me what to write. -2 to the -1. What is -2 to the -1? What is -2 to -1? Negative -1/2. Very good. 1.47. Negative is staying negative. 2 to the -1 is 1/2. So I have -1/2. What is the -1/2 minus 1? -1/2 minus 1? -1.5. Yeah, 1.4. Or -3/2 is whatever work for you. Okay, now we have 2 points. So again, I think if you make a mistake, it comes from the calculation. But you can check the graph. If the graph is very creative, like you go over the place, that means something wrong. They can only fall into 4 types, right? The one that we introduced in the beginning. -1, -3, -1. This is -1. Oh, let me make it a little farther. So -1, -2, -3. So right here. 0, -2, 0, -2 right here. 1 and -1.5. So 1, -1.5 right here. All right. So to answer your question, Mark, you see that this one they can never go above. See that? If you get something like this, like on the 4 types, then it's correct. If you get something like crazy, fancy, then it's not correct. Okay. And erase it. Let me know when you want to take time. Okay. Otherwise, just keep moving. Can I erase it now? Yeah. Okay. All right, 2 down, only 2 more. Very fast for this. All right, for this one, I want you to do it. And whoever come up with the fastest way, there's the best way to do this. I'm gonna give 3 points. Do this, raise your hand if you have any idea. The reasons that I say there's a thing that can make your life easier and you can make less mistake is write this one down. Always convert fraction. The fraction gonna throw you off. The fraction gonna mess up with the calculation. So the tip is always convert the fraction. Okay. How do we convert 1/3 to 3? What is it equal to? Yeah, but how do I convert this? I cannot make them the same like this. What do I need to put it in? Come to? Huh?
Negative for x.
Yeah, negative to exponent. So 1/3 equal to 1.87. 1/3 is 3 to -1. Do you agree? Yeah, right? 1/3, 3 to -1. So I changed 1/3 to 3 -1. Let's see what happened. So negative still stay outside, so negative stay the same. Now 1/3 become 3 to -1. And then I have negative x. So what do I do with this power? -1, -x. Do I multiply them? I add them or subtract them? When you see it like this, power and power, what do you do? Multiply, right? So multiply them, I have negative this stay outside, and negative 1 times negative x. What is negative 1 times negative x? Just x, right? Just x. So negative 3 to the x. You see, this gonna help you a lot. You're not making any mistake on the calculation. Yeah. Because here you use a fraction, you use a negative, it's gonna be through you up somewhere on the calculation. Okay. Any question? Any question? Okay. All right. Where is the horizontal asymptote? Where? Where is the horizontal asymptote? X? Yeah, 1.4 lambda. This is the horizontal asymptote. Okay, 3 point. Now plug it in. Negative 3 to the power x. X is negative 1. So what is this? What is negative 3 to the negative 1? Huh? What is negative 3 to the negative 1? Negative 1/3. Negative 1/3. You have a negative. Yes, 1.3. Plug in the 0, negative 2 to the power 0. What is this? Is that 1 or negative 1? Negative 1. This is there's no parenthesis. The negative 1. Okay, 1. So negative 3 to the power 1. What is this?
Negative 3.
Negative 3. Very good. Okay, so I have negative 1, negative 1, and negative 1 over 3. Negative 1 and negative 1 over 3. Let's say it's right here. 0, negative 1, 0, negative 1. Let's say right here. 1, negative 3, 1, negative 3. 1, 2, 3. So right here. Because the number is 3 right now, you can see it's more steepness, right? It decay faster. The rapid like literally like go very fast. Yeah. Any questions? Okay. Can I erase it? Yeah. Okay. So always convert fraction. Okay, always convert fraction. It's going to make your life easier. Less mistake. Calculate easy. Get the full point. Oh, I think okay. So this is the last one. No, I said 6, right? What a symbol is it? Is that 6? What number is this?
5.
Only 5, right? Wait, what did I miss?
I think the first thing you marked as 1, 0.
Oh, do we have this example? Did we do this one? Oh, okay, so that's the one I'm missing. Okay, so 3 to negative x plus 2. Let's do that. All right, can anyone tell me where is the horizontal asymptote? Down to or up to? Up to, very good. It's 2, so this is 2. So this is the horizontal asymptote right here. What are the 3 points? What 3 points?
1, 0, and 1.
Right. Is it easy, right? So 3 to the negative. Remember, you have 2 negative right here. Negative already there, and negative on the number we're going to plug it in. So there are 2 negative. And that might become
1.
Yeah, positive 1. And then 3 to the power 1 plus 2.
55.
65. Very good. That's only 1 point mark for participation. Then you plug in negative 0 is still 0. Yeah, so there's nothing to worry about. 3 to the power 0 is 1. 1 plus 2 is 3. Last one, 3 to the power 1. But you have the negative already there. So I have negative, plug it in 1 plus 2. What is 3 to the negative 1? Not 1 over 3. Okay, be careful. This is not negative 3. What is 1/3 plus 2? Do you know how to add fraction? 7/3, very fast. So for those who want to review adding fraction, if you want to add a fraction, you need to have the same denominator. So 2, that's mean 2/1. How can I make them the same? Times 3, right? Times 3. Times the other number. So 1/3 plus 2 times 3 is 6. 1 times 3 is 3. Now they have the same denominator, good to go. Now take care of the top. 1 plus 6 is 7/3. That's 7/3. What is the estimation of 7/3? So 6/3 is 2. So I know this one going to be larger than 2. Yeah, 2 point something, right? 2.213, maybe, right? I think. But I know because 6/3 is 2, and this is 7/3, so it is larger than 2. When you wrap, you don't need to be exactly number. You can estimate for this time. You can estimate. So -1 and 5. So this is 2, 3, 4, 5. So right here. 0, 3, 0 here. So this is 2, so 3 right here. This is 3. And then 1, and then 2 point something. So 1, and then above 2 a little bit. Okay. Now connect them. Oh, I have question. This one is for you. Do you wonder where this is going? It's going to the infinity, but is it ever touch this?
No.
Good. It's never touched this. Let's keep going, close to that, approach that, but never touched it. It never touched it. Good. All right, we good? Okay, last sample. You probably have 50 minutes. All right, can I erase this? All right, 6. No. Let me write more like this. Okay. What is the first thing you need to do? You should do, not need to, what you should do to make your life easier. Convert the fraction. 1.20. How can I convert this? Negative, okay, negative first, and then what do I write next? Negative what? 1? X? 1?
-4 with the power of -1.
-4 to the power? Richard. X?
1.
Combine those two and you get together. Negative what? Huh? Come on, this is not a hard question. You have 1/4 to the x. Now I'll make it become 4. 4 to the power what?
-1. X over 1.
Negative 2x. This is getting more fancy now. Negative what? Is it negative? Negative what? Negative x. Is this 1/4 x equal to 4 to negative x? Did you say it? Who said that? Risa? Yeah, to give 1 point to Risa. Maybe I missed it. Okay. Do you remember this? If you have a negative, you need to bring it down to make it positive. So now it's already positive because we don't want a fraction. We bring it up back, then we need to have negative x. Okay. That's gonna help you to not making mistake on the calculation. Okay, -1. So I have -4. The negative already there. So make another negative. So there's how many negative here? 2, right? So negative become positive. I have 4 to the power 1 plus 2. What is this?
Would be 1/4 plus.
What?
The -1.
The 1 is just gone, right? Power 1 is just gone. Anything to the power 1 is nothing. What is negative 4 plus 2?
Negative 2.
Negative 2. Negative 2. 0. Plug in 0. So we have this 0 plus 2. What is that? Negative 4 to the power 0 is
1. Negative 1.
negative 1. Negative 1. There's no parenthesis, remember. So negative 1 plus 2 is 1. Very good. Negative 4 to the power negative x. But x is 1. So it's going to be negative 1 plus 2. What is negative 4 to the power negative 1? 1 4?
Oh. Oh, negative 1.
Negative 1 4. 1 4 is negative 1 4. You have a negative outside. Be careful. This thing, even though you think, oh, it's just a minus sign, but it's true of everything. That's math. Welcome to math. What is negative 1 4 plus 2? Very fast. Very good. We won't more too much. So 2 again, if you're not sure how to do this, because 2, that means 2 over 1. So I multiply to the other number, the other bottom number. So multiply by 4. So this is going to be 8. And then 1 times 4 is 4. Now they have the same denominator. Good to go. That means I can work on the top. Negative 1 plus 8 is 7. 7 over 4. What is the estimation of 7 over 4? I know that 8 over 4 is 2, right? So 7 over 4 is less than 2. Yeah? It's less than 2.
Oh,
Less than 2. Anyway, where is the horizontal asymptote? Up 2. Very good. 1.4 Orlando. Very fast. Sophia, you say 2? 1.5 Sophia 2. Okay. Negative 2 and negative 1. I mean negative 1, negative 2. Negative 1. Negative 1 here. Negative 2. 1, 2. Right here. 0. Did you do it? Oh, yeah, it's correct though. Because I have negative and positive number, I just think. Okay, that's correct. 0 and 1, 0 and 1 right here. So I never cross this still. Because this line is like 2. So we still don't not crossing that. That's good. And then 1 and 7 over 4. So 1 here. Again, 7 over 4 is less than 2. So I can just plug in something right here. That less than 2. Okay. I connect this. All right, you can just connect those 3 points. You don't need to go too far. Yeah, that would be it. That would be it. Any question for this thing? Yeah? Okay.